Hello, welcome back. Today we're going to be talking about what's called scientific notation, which pretty much in essence means the language of mathematics used in pretty much any science field that you can think of. You may have had a little exposure to this during your physics classes or other science classes, but it's a very huge prominent thing in chemistry, so we're going to focus on learning about that or refreshing your memory today. So the importance of scientific notation. It is used to express very small or very large numbers in a condensed literature form. So instead of writing, 100 billion all the way out, we try to condense it down into some notations that means the same thing as 100 billion, but it's just written a little differently. So it consists of two parts. First off, there is a number between 1 and 10 that's usually used at the very front of the notation. I'll kind of explore that a little bit further on here in a second. And then it's followed by an exponent, where it's 1 through 10 times 10 to the something. Okay, that something could be positive or negative. The exponent is determined by the amount of times the decimal has to move to where there is only one number in front of the decimal at the beginning. That seems a little weird to say, but I'll help demonstrate that here in just a little bit. So, for example, if I take 150 million, we know that the decimal is way down here at the bottom zero. But the scientific notation for 150 million would be 1.5 times 10 to the 8th. So what I did was I took this decimal and I said 1, 2, 3, 4, 5, 6, 7, 8. And I put the decimal right in between the 1 and the 5 where there's only one number on the left-hand side of the decimal, and the exponent comes from the number of times I had to move the decimal over. Now, since I had to move the decimal to the left to demonstrate a higher number, the exponent here is positive. But if I was demonstrating a lower number where I had to move the decimal to the right, then it would become a negative number. And again, we'll dive into that here in a second. So the rules of scientific notation. First rule, large numbers will be demonstrated by exponents of positive values. So that 10 to the 8th meant a positive, larger value, millions, billions, trillions, so on and so forth. And the decimal has to be moved from the right-hand side, so we went from right to left. The second one is that small numbers will be demonstrated by exponents of negative values. So again, it's the vice versa of that. So instead of moving the decimal to the right, I'm moving it from the left. So I'm going from left to right instead of right to left. So those numbers will be negative on the exponent. And then, for example, all numbers before the exponent are significant, which we will dive into significant figures here. Either you've watched it before, or we'll dive into it in the next video as well. So don't worry too much about that. So a couple examples. We're going to create a proper scientific notation for the following numbers. So what I want you to do is just as I present one, if you need to pause the video and see if you can write the scientific notation for it, go ahead and recheck your answers. Otherwise, if you're really comfortable with this stuff, you can kind of go straight through this video. But I highly don't recommend that. Take some time, kind of refresh yourself if you need to. And if you have any questions, please come see me. Or if you need to watch some other videos or something like that, feel free to do that. So first one, 99.452. So what I want you to do is that I want you to create a scientific notation for this number. One thing you have to ask yourself is that it's a decimal number, but is it smaller than 0? If it's smaller than 0, or smaller than 1, smaller than 1, then you might want to start thinking about negative exponents. This is not the case. So just take a second, see if you can figure this one out. All right. So what you get is 9.9452 times 10 to the first. So what we did is that, if I can get my mouse over here, took this, I said that it was greater than 1, so I know that my exponent is going to be positive. So I'm going to say, okay, I've got to move this over to a number of spaces until I have one digit in front of it. So I go to, where did I go? Okay, go 1 space, so then I get 9.9452. Since I only had to move it 1 space to the left, it goes 10 to the first. Okay. Next one, similar one, so take a second and see if you can determine that. All right. So this one is 2.56 times 10 to the fifth. So again, what I did was I said it was greater than 1. which means I know that the exponent is going to be a positive value because I'm demonstrating a large value. So I had to figure out where the decimal is. So the decimal is going to be right here to the right of the 0. So I have to get it to where there's only one digit in front of it, so that 2. So I'm going to go 1, 2, 3, 4, 5. So that's where I get the 2.56, and since I have to move it to the left 5 times, I get 10 to the 5th. All right. Again, take a second, see if you can do this one. All right, so this one, it might be a little tricky to some of you guys because of that 0 that's in front of it. But what it comes out to is actually 1.05. So it follows the same rules. Even though that 0 is in front of it, that 5 is still considered what's called significant. So it's a significant figure, so we want to incorporate it into that decimal. When it comes to this number, so again, 1.05 times 10 to the 9th, and that's because I started from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you get 1.05 times 10 to the 9th. So this one is on the opposite of that spectrum. So we know that it's less than 1. So we know that we're going to have a negative exponent, and then we're going to be moving the decimal to the right, okay, instead of the left. So that's where we need to focus on that. So you have to ask yourself, is it greater than 1? Is it less than 1? And that'll determine on what type of values your exponent will be and where your decimal needs to move to. So we want to follow the same rules. So take a second and see if you can try to determine this one. Okay. So what it comes out to be 2.45 times 10 to the negative second. Okay, and the way this works is that we have the decimal over here. We know that's where it is. But we want to get to where there's one significant value in front of it. This significant value, this 0 does not matter because it's in front of the 2. Now, if it was 2.045, that would be a different story. But since it's in front of this 2, and again, if you need to refresh or, on significant figures, watch the significant figure video. Otherwise, we'll be watching that here in a little bit in class, so it'll make a little bit more sense. But we're taking the decimal and go 1, 2, and that's where the 2.45 comes from. And since we moved it 2 to the right, it's negative 2. Okay? So let's try this one. All right, so you should get 5.05 times 10 to the negative 6. Again, same rules. Decimal's way over here. We do not care about these zeros that are in front of the 5. Now, since these two 5s are on each side of a 0, this 0 is considered significant. So we know we're going to incorporate it into that value at the beginning there. So I take my decimal and go 1, 2, 3, 4, 5, 6. That's where the 5.05 comes from. And since I moved it 6 decimal places to the right, it's negative 6. And see if you can try this one. This one's a little tricky. So again, in regards to significant figures, since there are 3 zeros in between the 7 and the 5, they are considered significant. So you have to incorporate those into that total right there, because they can change with the experiment. They are experimentally significant in regards to your data and everything like that. So even though it looks weird, this is actually the correct scientific notation for it. However, the 0 in front of the 7 does not matter. So that's why we don't incorporate that. So you just move the decimal place over once, and that's why you get 7.0005 times 10 to the negative first. So from scientific notation to ordinary numbers, you should be able to read ordinary numbers to scientific notation, but you should be able to read it backwards too. Because you may be asked questions that say, convert this scientific notation number into an ordinary normal number as well. So to go from scientific notation to an ordinary number, it's just the reverse of what you did. So if you had to move the decimal place to the left for a positive value, greater than 1, so like the 100 million or whatever, then, to go to ordinary number, you would move the decimal place to the right, and then vice versa when it comes to smaller numbers. So a couple examples. If I had scientific notation of 3.01 times 10 to the 5th, I know it's a positive number, which means I had to move the decimal from the right to the left. But to go to ordinary number, I have to move the decimal from left to right now. So I move it back 5 places. So the decimal was originally here. You go 1, 2, 3, 4, 5. So that's why you had to move 5 places to the right. So the reverse of what you did for scientific notation. This one, since it's a negative number, I had to move the decimal from left to right, which means now I'm going to go from right to left. So now I'm going to go, from the decimal was originally here, I go 1, 2, 3 to match that 3 there. And that's what the ordinary decimal would look like. And then this one, same thing. I had to move it from the right to the left, so now I'm going from left to right. So I start off with the decimal here and I go 1, 2 to match the 2 here, and it's 550. So a little extra practice. At this point, I mean, if you feel comfortable, you're more than welcome to, stop this video. Otherwise, this is some extra practice for you. I highly recommend it. Otherwise, if you have any further questions, feel free to come and talk to me. But I'm going to go through these real quick and explain those for those that may still not be getting it a little bit, so no worries there. So to convert the following numbers to either scientific notation or ordinary number format. So the way your tests will go in your quizzes is I may give you scientific notation until you give me the ordinary number, or I may give you the ordinary number and tell you to give me scientific notation. So this is a similar question that might be on a quiz or a test or something like that. So we have, let's see, what is that, 4 million right there without the commas. So I give you an ordinary number, so I want you to convert it to a scientific notation. So take a second if you need to do that. You should get 4.0 times 10 to the 6. So again, you want only one number in front of the decimal. That 0 to the right, you can consider it significant because you still want a kind of a decimal placeholder since you are moving the decimal. But again, you start off here and go 1, 2, 3, 4, 5, 6, and that's where you get 4.0 times 10 to the 6. Now I give you scientific notation, and now I'm telling you to give me the ordinary number. So take a second to see if you can determine the ordinary number from this. So you should get 0.0005. Now you're probably wondering, why is there not a 0 in front of this? Sometimes you may not give that. Maybe the decimal isn't significant, so it can go either way. It just depends on what the experiment is, what the parameters I set, and the question. So don't get so frustrated over the semantics of that. Just follow the rules. In either scenario, you should come out with the right answer. But you can see both of them happening depending on what you're reading or what you see in the textbook or what I put on the paper. So just be aware of that. But again, so we know that the decimal is to the right of this. And since it's negative, I'm going from right to left now. So I go 1, 2, 3, 4, and that matches the 4 over here. So that's the correct number. This one, same thing, give me scientific notation for that, so take a second to do that. So you should get 8.45 times 10 to the negative 7th. I'm going to start rolling through these. If you have any questions on these, please let me know. 3.73 times 10 to the 3rd, so give me the ordinary number for that. You get 3,730. Okay, because that decimal will move 3 places, so it's going to go 1, 2, 3. So there's not a number over here, so you have to fill it in with a 0. So that's where that 0 comes from. 2.98 times 10 to the 8th is a bigger number. And you should get this, so you're going to have 2.98. Now, one thing you can kind of once you start getting really good at this, you can start noticing it's like, okay, how many places do I have to move to get rid of the 9 and 8? Well, 2 places. So 8 minus 2 is 6. How many zeros are over here? Well, there's 6 zeros. So that's kind of a quick way of doing it. Instead of counting everything out, if you count up the places that already have numbers and then the places you have to fill in with zeros, just take this 2 spaces here minus the total on the exponent, and that's the number of zeros you have to add. So that's kind of a quicker way. I would recommend doing that after you've had a lot of practice. Practice do it moving the decimal as you go, but if you get comfortable, maybe start working with that shortcut. All right, so that's the end of this video. If you have any questions, please feel free to come and talk to me. I'm available as much as I can. Email me. Watch some different videos if you need to. Sometimes my videos aren't the best for you to kind of learn from, which is completely okay. I get it. Some of you guys may learn from a different style. So I highly encourage you to look into other recordings if you can find it on YouTube, or talk to some of your other science teachers if they have any other options for you, or feel free to come talk to me, and we can try to maybe do it a little bit more visually or in a different algebraic or mathematical way that may make more sense for you. So I'm willing to work with you. Please come talk to me if you can, and hope to see you soon in class, and see you in the next video. Thanks.